we're going to work through an example. Hopefully it'll only take 15 minutes or so. Again, we're going to try to combine some of the stuff we didn't work through yesterday with just some of the stuff I showed you just now. It would have been cool to put STM in here. Actually, Brandon, maybe if you're up for it, if you're still hanging around, maybe you could spin up some analysis with STM in with this data. Just that'd be cool to post to the. Actually, they have your vignette though. They probably don't need to do that. But anyways, the vignette is great. It works through all the many functions of STM. So okay, so what I thought we might do is get some Twitter data and then try to visualize some text networks or n-gram networks using that Twitter data. So what I've done here, or what Taylor's done, is post the data that describe the Twitter names of all elected officials in the U.S. to, or sorry, not all elected officials. I think it's all Congress, senators and Congress people, I think. But in any event, it's hosted on the GitHub. So in this first line of code, we're just reading in that list of elected officials. I'm not sure where it is. So you'll see here, we've got the name of the elected official. This is the Twitter handle. We've got a location, and we've got their About Me section. We've got a URL, and then we've got a follower count and friends count. We actually aren't going to do anything with all of this data, with a lot of this data, though an interesting extension of this would be to use some of these attributes either as metadata in STM or as attributes in the network analysis. What we're going to do first is pull these the last 100 tweets from each person. And so the way we're going to do that, going back to our main code here, we're going to use the Twitter package that we used yesterday. It's a great package authored by Pablo Barbera that, again, is doing a lot of the work for us by constructing the URLs necessary to request data from Twitter's RESTful API. So the way we're doing that is we're using, first we're authenticating. Remember yesterday we talked about credentials and how you need to register as a developer with Twitter in order to collect data from Twitter. And you have to go to apps.twitter.com, and there's a link to that in the slide from yesterday morning. And when you go through that process, you get your consumer key, consumer secret, access token, and access secret on the credentials page. And for this code to run on your machine, you will need to change the text for each of those that's in green here, and put in yours. They'll be longer, and then you'll be asked to choose whether you want to directly authenticate or store credentials on your machine that can then be used later. It's probably easiest to directly authenticate by pressing 1. And then once you're in, then we can start pulling data. The first thing we're going to do is create a blank data set where we can store data. In this case, we're going to be pulling the 100 most recent tweets from each of the people in the data frame we just created in the first line of code that reads in the names of the elected officials. So here we have a loop that's going to take us through and collect that data. You know, we have all levels of coding here, so I think it might be useful for folks who haven't done a lot of coding just to work through one way to get these data. In this first line here, we're simply telling our loop that we want it to repeat the steps within these brackets the number of times that's equal to the number of rows in our data set. So in this case, we're going to repeat these instructions 562 times because that's the length of this data set. here we're grabbing first the screen name of one of our elected officials. I'm just going to arbitrarily give I a value of 2. And then when I run this line, oh, sorry, I'm actually not authenticated. I'm not going to run this code because it'll take too long. But if I did that, we should see the second person named in our data frame. We then create this object user. We can then use a variety of functions within the Twitter package to extract information about that user. This user timeline function pulls the most recent tweets. We pass a value of n that says we want 100 of the most recent tweets. We then create another object called tweets. And because oddly enough, some of the senators have Twitter accounts but appear not to tweet. I think it was just one person. I can't remember who it was. We had to write this little if loop here that just says if there are no tweets collected in this step, don't populate the data frame. If there are tweets though, we want to turn our tweets object, which is a list, into a data frame using this handy tw list to df function. And now we have a data frame called tweets. And then we're simply going to create a row of data that has the elected official's name in the first cell. And then in the second cell, we're going to put all the tweets together into one long, really messy string. If we wanted to break things out by time or something like that, we would need a more sophisticated data structure. This is just a really simple example, so we're going to get kind of silly results. But to paste them all together, we're using this paste function with a collapse argument. That's just telling it to paste all the text together instead of keeping it as separate elements. And finally, we're populating this blank data frame that we created up here with that row of data. And then this final line here, we are telling R to wait 1 second before repeating the next step, and that's to avoid rate limiting. Remember that if we try to request too much data too quickly, Twitter will tell us you can't do that. And so we can either, here I just arbitrarily guessed that it would be okay for me to make about 500 calls within 500 seconds because I have a lot of experience doing this. But if you wanted to check, a nice property of Twitter's API is that you can check your current rate limiting info. There's a get curl rate info function, I believe that's what it's called. And then you could set that, instead of using a 1 there, you could use an abstract variable that's pulled from whatever your current rate limiting is. And that could, especially if you're dealing with a huge amount of data collection, like Kiven's problem, that might be a good way to make your code more efficient. But here we're just this is some pretty rough stuff. We're just going to pause for 1 second. And finally, we're printing the value of I. This is simply for the purposes of debugging. This is like when I got to that senator the first time I ran this loop that had no data. I wanted to know what's going on. Once I knew which value of I it was like 53 or something. I then went and looked at my data frame, got that person's name, put it into Twitter, and saw what's going on. We also might want to do this to monitor the speed of the code, particularly if we have something really gnarly going on at one step. We can see how long it's taking. There's probably better ways of benchmarking speed, but for now, it's a crude method. So instead of, again, letting this all run, because it would take 532 seconds, or probably about twice that, because the step of pulling the data from Twitter probably adds another second or so. I made available a elected official tweets.rdata data frame on the GitHub page. So you'll need to put this in your working directory for this to load. We don't have it linked to GitHub here. But once you get this loaded, you should see this data frame here. Takes a while to load because it's got a lot of characters in it. You know what? I'm gonna I've just got a really messy workspace here. I'm going to step backwards because we're seeing steps that I'm about to take, and I just don't want that to create confusion. So I'm gonna load that. I'm gonna load that file, that .rdata file. Let's see here. Where's that file? Here it is. Okay, so here's our data. We have the screen name, the Twitter handle, and then all of the tweets posted together. Again, that's kind of a silly choice for some reason. It depends really what the goal of the analysis is. But you know, especially given that tweets are so short, and especially if someone wanted to use these data to do topic modeling, we probably need, in my experience, you know, a few sentences is just far too little to train a topic model on. Certainly you see people do it in papers, but in you know, lengthy experience applying it to social media data, it usually doesn't do such a great job. If you're looking at an individual tweet, especially, Facebook posts are sometimes a little bit longer, but I think binning them is a nice solution depending on what your data look like. Brandon, have you ever had any luck topic modeling with tweets like just a 154 character tweet?
It's hard.
Yeah.
I mean, aggregating them tends to work well, but and I think it depends on how focused they are. So we've done stuff with very short, open-ended survey responses, but it helps that it's the answer to a question, right? And so, so I could imagine a Twitter forum where you were doing something like that, like where like it was tight enough in its scope that worked, but just like, let me have all the tweets and like run a big topic model on it.
Right.
Like the topics might be reasonable, but the topic portions, you know, they could be kind of rough.
And in so Ben is talking about a nice paper, and I think it's AJPS with the open-ended survey. Is that the one you're talking about, the open-ended survey?
Yeah.
So to what extent, though, because you had a lot of metadata for that study, right? Because you had everybody's survey. So do you think that helped the classification, or would you? The question behind my question is, should people use STM for individual tweets?
I mean, I think if you can avoid it and can get to longer documents, then I would seriously consider that. I think if you have good metadata and you're, you know, like then that's good. The STM kind of basically builds like a hierarchical model that ties the tweets together, which is great.
Yeah.
That can also unsettle people because it ends up meaning that like when you think about the posterior on a given document, it's really heavily influenced by that document.
Yeah, exactly. Yeah.
Which is not true prior because it's being learned by the model, but still it unsettles people.
Yeah. Great. Okay. So I clumsily forgot to name the columns of this data frame. Sorry, I was writing this morning, so it's not pretty. Next, we're going to do this process known as lemmatization. This is again very similar to stemming. There's a new package called TextStem, written by Tyler Rinkler, who is the author of the QDAP package that Rochelle mentioned earlier. It's a really wonderful package, all sorts of utilities. Before this package, you had to run a native lemmatizer on your machine, or use a API at Northwestern that was trained on a really old corpus of Old English text, and so it wouldn't be at all useful for something like social media data. So we're loading that library. Obviously, you'd have to install it if it's not on your machine. One of the folks here reported that they had an older version of R and needed to update in order for the package to run, for those of you who are just kind of installing packages for the first time. And within that TextStem package, we've got this lemmatized strings function, and that takes each word in each line, which is again 100 tweets all smushed together, and transforms each word into its lemma, which is equivalent to its stem form. We can look at some examples if we run this code here. Let's see. There we go. I probably should browse this in a different way. Okay, here we're looking at. So here we have and it come instead of and it comes. A stemmer would have done the same thing. But you'll see it uses, I think, some of the WordNet style techniques to observe syntactic similarity between words, and that's the value added of lemmatization. Otherwise, again, it's very, very similar to stemming, or the Porter stemmer that most people use. Unfortunately, I just got this new computer and I updated to the latest OS, and so I'm having Java issues, and didn't want to compromise my slides for future days, so I wasn't able to use the OpenNLP package, which is what I typically use for part of speech tagging. So I wasn't able to, in this worked example, break out nouns and noun phrases, which is pretty critical for, I think, for capturing the content. So again, this is kind of a silly example, but assuming you aren't on High Sierra or whatever I have on here, you should be able to use the OpenNLP package. I believe it's the tag_POS package. Is there another package that you know of that doesn't use OpenNLP?
Yeah. So
cool.
Ken Benoit just finished a wrapper around the Spacey package.
Nice.
It's called Spacey R.
Spacey R?
Yeah. So Spacey is this claims to be
with
like
an E?
Industrial strength, like natural language processing.
Uh-huh.
But it's and it's great, but it's a Python dependency.
Okay.
And it also had install problems, but
okay.
As best I understand, Ken has mostly solved these, so
cool.
It made it easier.
Sounds like Jeff has. There's no E. Okay, thanks.
The CY for Python.
Oh, okay. Cool. Yeah, there's a few other. I mean, I think there was an older NLP package too. I'm not sure. Does anybody know if that's deprecated now? I've always used OpenNLP. I don't. Anybody know? Anyways, kind of getting into the weeds here. So next, we're kind of by hand doing the pre-processing steps. The STM package is as Brandon mentioned, has a really nice what's the function called, Brandon? Text processor that will remove numbers, punctuation, move text to lowercase stem, and is that it, or and you have options, I think.
Document matrix.
Right. Yeah. Exactly. Yeah. So that's a really nice function, by the way, folks. Yeah. Yeah, Mike.
So could you explain briefly what you would have done?
What's that?
Could you explain briefly what you would have done with the POS tag?
Yeah. Sorry. Okay.
Drop everything except verb and noun phrases, or?
I would. Again, it depends on your research interests. This is also where you could tokenize n-grams. So there's a variety of text utilities. QDAP has some nice ones for extracting n-grams, for example. But yeah, you'd want to remove all text that is not whatever you're interested in, be it noun phrases, nouns, or if you're only interested in adjectives, or if you wanted to say do the polarity thing that Anjali was talking about, then you'd of course need to break it out and then add signs to the weights, which would complicate community detection a little bit because community detection techniques vary to the extent they can handle weighted data and valued data. So it would get a little hairy, but I'm sure there's at least one community detection method that could handle weighted valued data. I'm not positive about that, but I'm pretty sure.
For weighted networks?
Yeah.
Yeah, there's a random walk based.
Oh, cool. Okay. There you go. Yeah.
I think it's called walk trap in R.
Oh, yeah. That's right. Yeah. Cool.
Sandra loves it.
So, sorry?
Sandra loves it.
Yeah. Everybody kind of has their favorite community detection method. It's a thing among networks. But, okay, so, and it's the one that validates their theory. No, I'm kidding. Definitely kidding. Though often that's not the case. Anyways, that's another story. Don't get me started on layouts. Okay, so basically here we're just we probably should have used the STM package to do this preprocessing. Would have been a lot more elegant. Instead, I'm just using some basic grep to remove numbers and punctuation, and I'm using this toLower function from, I think, Iser. And all we're doing again is saying we don't want to treat the word God, capital G, and the word God, lowercase g, differently. Although again, we could talk about whether that matters. And we're also obviously removing numbers. And also, I think there's a better way to do this because when we remove the punctuation, we wind up with a lot of isolate, I's and S's, as I recall when I did this morning. How do you handle that in your preprocessor? Do you remember?
I think I'm pretty sure we just replace it with. You look like you're replacing it with a space.
Yeah, that's right. Yeah, that makes sense. Yeah.
But
That does raise a good point, folks, that if you have a space in your data or multiple spaces, those can sometimes be confused as objects you might analyze in text analysis. So there's functions like strip white space that might help you clean that up. But again, Brandon's function will, I think does that as well, right?
Yeah, it does. Yeah, also strips white space. The other thing is if you want like a little bit, like if you want it fast, and like without worrying about it, text processor is great. If you want like a little bit more control, the Quantita package is like fabulous for all this kind of stuff.
Huh. Okay.
Yeah, and that is great. Ken has great documentation up for it.
That's great. Yeah, because for those of you in the R community, TM has long been the go-to, but it has its well-known limitations. So that's a very welcome development. I haven't used it yet. I think Taylor has too, right? So if folks want local knowledge, Brandon and Taylor, I'll volunteer you. Okay, next we need to now create a person to term or n-gram or whatever we're interested in projection. Here we're doing the connecting people by their shared use of words rather than connecting words to each other. Like the Rule et al. Paper does. That's the one with the State of the Union. This is more the other paper, my paper, that we're following here. This is a handy function that just takes this text data and breaks up each word in that long string and reshapes the data to long format. And I don't remember if I ran all this stuff. So it takes a second, but now you'll see we have this really gnarly, huge data set that's the name of the senator and then lemmatized tweets. And indeed, we have this problem here. So again, if folks want to, the other day someone cleaned up the scraping code. If anybody catches bugs, please fix them and then send them. Do you mind handling uploading the? So if you catch a bug, please send the fix to Taylor and she can fix the GitHub. That would be a great help. Thank you. So if someone wants to hack that through right now, that would be cool. Again, I'm lazy here. I'm just getting rid of the variable just so we I don't know why, I guess. And then we don't want to create multiple ties based on the same word in this case. This is another step that I guess is a little controversial. If someone used the same word a lot, we could create our weights that way. Here using this unique function, the size of this data frame splits in half because now we only have the unique words that each elected official is using. And you'll see this data set's huge because there's 100 tweets that have, 100 words each, so it's really big. And then we have 500 elected officials. I guess I did try to kind of drop some of those one-word lemons. I don't remember why I didn't do that. Anyways, if anybody's working on that, maybe that code's useful. Now we have to create the term frequency inverse document frequency metric. Again, there's probably a much better way of doing it. Maybe Quantita does it, or do you know offhand?
I'm sorry, my mind.
Oh, that's okay.
What was the statement?
Do you know if Quantita does TF-IDF?
Oh, yeah.
Okay, yeah. Figured, yeah. And I think, I know TM does it as well. So again, it was early. I didn't have coffee. There were better ways. It's almost always the case, huh? This is the data table function that Brandon mentioned earlier, it's really great and for like kind of database style problems, especially when your data are getting big like this one is. It's pretty fast as well. Though these next few lines take a minute. And what we're doing here is creating a list of word counts so that we can painstakingly create the term frequency, inverse document frequency by hand. I'm just, again, changing some column names. And here's the line that we're creating the inverse word frequency, term frequency, inverse word frequency. Here we're getting our word counts. So you'll see we actually have a lot of emoticons in our data set. Interesting, the lemmatizer didn't get confused by those. I'm not sure, maybe it just doesn't lemmatize when it doesn't recognize a character, but that's obviously a challenge for a lematizer, an emoticon. Okay. And now we're going through the steps of creating an adjacency matrix based upon these overlapping use of terms that's weighted. That's the sum of the TF IDF of the terms that overlap any two actors. We're going to use the reshape package here. And then this is a handy matrix function that creates our adjacency matrix, which I think I borrowed this line of code from Solomon Messing, who was working in I think Dan McFarland's lab at the time. That's why I don't know why it's called ARO. I should give credit here. Okay. And now in R, the name of the game in networks is iGraph. There are several other packages, SNA, but iGraph, it's also available in Python. It's a huge, very powerful package that is really well documented, really well supported, and basically we're gonna use iGraph to transform our adjacency matrix into network data, and that's important because network data requires a list of nodes and a list of edges in order to perform a lot of both the and the nodes in this case have an attribute, or sorry, the edges in this case have an attribute, which is the weight. So we can go ahead and use this graph adjacency function to create that network. Oh wait, I think I skipped this step here. And now this is just a little, sneak peek at the data. You'll see there's a lot of, this is a somewhat sparse matrix. A lot of people aren't using the same words. Remember, we've dropped a lot of common words. Actually, no, we haven't dropped stop words. So it's a little surprising there aren't more shared words, I think.
Since you use TF-IDF, all of those are going to...
Exactly. They're going to have a very low weight. Exactly. Yeah, that's right. Yeah. And here's here's this vexing step. Like, what constitutes a meaningful tie? This is we have an extremely dense network. Even though it's sparse, it's also dense in that the values are very low. These TF-IDFs are very low, but there are a lot of people who have very weak ties to each other. So we have to make a somewhat arbitrary decision about what the cut point might be. I've had a lot of discussions with people who know a lot more about graph theory than I do, and I haven't gotten a clear answer for kind of a best practice. I mean, like, I don't know, bottom quantile or something like that seems arbitrary. There's some, oh, do you have an idea?
I was gonna ask why threshold at all. So why not just avoid the arbitrary?
It's a perfectly reasonable question. I think it depends. I actually did it in the paper because, yeah, it's capturing some meaningful information to a degree. For this example, I wanted you to be able to see a network diagram and not a clump of hairy nodes. But that's a really bad reason. I think in most applications it makes sense not to prune it.
And what you could do is threshold for your visualization, but not your
Exactly.
analysis. The idea being
Exactly,
if the weights are so small, they
Exactly.
kind of come out in the wash.
Exactly. Yeah, good call. Okay. So you can or cannot drop weak ties. I think Josh is probably right that we are losing some information there that is meaningful. If you have to visualize, that's a nice solution. Prune for the visualization, but not for the analysis. I didn't have a visualization in my paper, so I just a network diagram. So I had that heat map that I showed you, so I didn't prune for that. Which is, I guess, another strategy for visualizing a really dense graph. Okay, here the credit goes to Taylor, who took my really crappy I-graph plot and made it pretty using this new wait, isn't it GG network? Or is it does G-Galley load GG network? Okay, so there's this new package that applies ggplot sensibilities, for those of you who are Hadley Wickham fans, to networks. And I guess it's called G-Galley now, or is it GG network? Used to be GG network, I thought.
Might be that.
Okay.
I learned
And then
all of this like 10 minutes ago.
Okay. In any event, oh,
Oh, you didn't load. You didn't
Sorry.
install
Kali maybe?
coding in public.
So fun.
Wait till your first embarrassing email pops up while you're teaching. What was it? What am I installing?
Right.
Someone help.
Yeah,
GG
you're
net.
fine.
Oh, that's a dependency. Okay, cool. All right. So I think Taylor sized the nodes by degree, right, Taylor? And so, oh yeah, here we go. Here's our key.
Obviously, if you have more network attributes, you can do all sorts of things.
Yeah, and that would be really cool, like to use followers. Another really interesting exercise would be to overlay the follower-co-follower networks and see to what extent social networks map onto text networks. It would be nice to have labels of who's who here to see if this makes any sense whatsoever. The other limitation here is, remember, this is just people discussing the same thing. It's not necessarily agreeing on the same thing. So if anybody wants to take a peek at the labels, I'd be interested to know if it makes any sense. Again, I hacked this together in like 40 minutes this morning, so I have no idea. Has anybody tried running STM on it, or any of it, or their own favorite text analysis technique? No. Okay, I think we should probably stop there because it's getting close to 1, and if we're going to stop back up at 1:30, I just want everybody to have an actual break. And if you want to leave the building or get some sunshine, do you want me to show you the group exercise before we leave? Or
Yes.
Okay, all right. Okay. So again, some of the feedback for today was that people were liking the group exercises, but that you wanted a chance to choose your own topics. So yesterday we did just random assignment to our groups, and today the exercise lets you choose the subject you want to work on, but not necessarily the people you want to work on. We'd like everybody to go to this list of text data sets. This is the one that I linked to on like one of the first slides this morning. It's just this Google sheet of text data sets I curate that may be of interest to social scientists. On Slack earlier today, someone said some of these are a lot easier to work with than others. That's absolutely true. If you are newer to text analysis, though, maybe it's a good challenge to take on one of those more gnarly data sets to learn some more basics of going from words to numbers. On the other hand, if one of them, or one that you add, remember this is interactive, so you can add your favorite data set on here, or even upload your own data, then we can build teams around that too. Obviously, if you do that, know that other people are going to be working with you on that data, so maybe don't share your dissertation data if you don't want it to go public. I think this is probably a public, but nobody will have to link, I guess, but it is a public Google Sheet, right? So yeah, share stuff you're comfortable drifting off into the ether. So put your name next to the data set that interests you most. The data set could interest you, again, for a variety of reasons, either because you want to learn more preliminary skills, or because it has a subset focus that you're interested in, or because you think it's possibly a good application for one or more of the techniques we described today. We could also break into groups according to the techniques, but I actually think it might be easier to, I think it might be more interesting to have the groups try to apply multiple techniques to each data set, because then we can start to do some of the benchmarking that I think Connor was mentioning earlier that would be kind of interesting. Once again, the goal is to help this build towards the group project the second week. That now the scary board of the Russell Sage Foundation might be coming to observe and pressure. I know I think they actually have, I think they have a board meeting that day. So I don't think, if people come, I don't think it's going to be, like a who's who of social scientists, but we might get one of the program officers who worked on this grant, who has interest in this field. So with that in mind, with the group project in mind, when you get together as a group, I think it would be worthwhile to discuss what interesting research questions can be asked with this data. Presumably people will have different research questions. If you then decide that you want to break into smaller groups, like 2 people want to do one thing and 3 people want to do another thing, fine. Go ahead. Also, we've got here, figure out which types of quantitative text analysis would be most useful to study this question. I'd say that's let's make that optional. If you start developing a project or some really cool analysis, that's more important than coding through this stuff concretely. But again, if you're new to this stuff and if you've never done text analysis in particular, maybe try to either be a fly on the wall in a group that's got a lot of coders on it, or if folks who don't have a lot of experience with text analysis want to group together, and then I can hang out with you, or Taylor can hang out with you, we can do that too. But as you can now tell, this is going to require you talking to each other. So I'm going to shut up and turn off the live stream. And so let's come back at 1:30. Unless, let me open it up though. Does anybody want to change this in any major way? We're all really cool with that. Yeah, it's Peter, right? We haven't.
Yeah.
Peter. Yeah.
What if I have a data set that I want to look at?
What if you have a data set that you what?
Like not one of these text data.
Oh yeah. So just add it to the list, and then assuming you're comfortable doing that. If you want to work alone too, I don't see anything wrong with that. I just think it's a shame not to take advantage of these lateral networks that you all can build here. Yeah.
I'll just say for number 6, if anybody happens to come up with anything really cool,
yeah,
I would love to see it.
Yeah, me too. Why don't we link that into our present? So earlier I mentioned that we were going to circulate a Google Doc where folks who want to present something, and again, that can be anything you want. It can be, hey, I know how to do this skill. That's a fine presentation. It can also be like, here's 10 minutes about my dissertation. If you want to get some feedback from the really smart people assembled here, I think that's a really great use of that time. But Matt and I just need to know how many people might want to do that so that we can start to figure out when to put those presentations. So maybe what we could do is if, Taylor, did you circulate that link yet? Okay, cool. Did you circulate the link on presentations on Google? Yes. So tell you what, if you're a group that wants to present, just put it there. and we won't get to it today, but we'll try to build it into probably next week, or we can have another working lunch like this. Tell you what, if you like the working lunch, please let us know on the feedback form. Just this 2 should be a 3, but maybe wait to do that till after the group exercise, because it would also be good to get some feedback about whether you appreciate being randomized or you like being able to choose your own topic. I think some of Matt's exercise over the next 2 days are a little more directed. Like I think he's gonna ask you to reproduce an article, I think, on Thursday. I'm not positive about that. So, anyways, I'm gonna shut up and have fun. I'll be here. Taylor's here, and let's come back to start at 1:30.
Just one note,
Oh, yeah.
like there's the link there, but Taylor, you also sent out a link that's where we actually are putting our names.
Right.
So make sure you're on that.
Oh, that's the original one. Sorry, that's my bad. Sorry.
Oh,
So that's my original one. Sorry, the reason we
You
Be
have.
able to edit that one, and the one in
shoot.
Slack. You
Yeah,
can
you
add
can-
yours.
Just go to the Slack one.
Okay,
Use,
Slack one.
don't use this link. Use the Slack link. This is the link I used to like
I think we should
show to like teach with and stuff. So if you put your names all over it, I can just delete them too. But just so that some people aren't in one and other people aren't in another, go to the link that Taylor sent to choose the text data set that you want to work with. Sound cool? Okay. All right, I'm gonna go turn off the live stream.